In this video, we'll learn how to implement promises in JavaScript. On the right, I've got my promise class, which at the moment is just an empty class. And on the left, I'm importing my promise class. And then I have a test suite that I've prepared for this video. Now I'm just going to start from the top and make this test pass one by one. So let's look at the first test. It says execute a function is called immediately. Execute a function refers to the function that is passed into the promise constructor. To make this test pass, we can just simply call the execute a function. It's the only argument passed into the constructor. Let's look at the next test. It says resolution handler is called when promise is resolved. So resolution handler refers to the function that is passed into then. And what this test is asserting is that when the promise is resolved with a value, then the resolution handler should be called afterwards with that same value. If we run the test, we'll see that we get an error. Promise.then is not a function. Okay, so let's first create a function called then. Next, we get an error saying resolve is not a function. So we need to pass a function to this execute a function. So I'm going to use underscores here to denote private methods. So I just create a method called resolve, and then I pass it into the executor. Now, it's important to remember to bind it to this, because otherwise we can't use this inside the resolve method. Now, of course, this won't still work. We still have to implement these functions. Let's first understand in which order these lines of code are executed. So first we create our new promise, so we call the constructor. Then we call promise.then and pass in this function. And then 100 milliseconds later, you see we're using set timeout, the promise is resolved. So because we first call then and then resolve the promise, that means inside this promise object, we have to store a reference to this resolution handler. The resolution handler is passed into then, and now we have to take that and store it somewhere. Now, in the interest of time, I'm going to anticipate some of the future tests here. I know already that it's possible to attach many resolution handlers to a single promise. So I'm going to create an array called resolution queue, and that's where we're going to put our resolution handler. Now that we have a reference to our function, we need to call it inside resolve. So here we iterate over the array. We always take the first one off the array, the first function, and then we call that function. And we call it with the value that is passed into resolve. Let's move on to the next test. So this one says promise supports many resolution handlers. Now, I said I would anticipate a little bit. So because we use this array and we push these resolution handlers to it, and then in resolve, we go through the whole array and just shift off all the functions and call them, this test should pass already. There we go. Let's move on to the next one. It says resolution handlers can be chained. So in this test, we call then, but inside then, in this handler, we return a new promise and we call then. Let's see what happens if we just run the tests. So we get cannot read property then of undefined. So the first thing we have to do is return a new promise in then. So let's think about this a little bit. We have to capture this promise, and when that promise is resolved, we have to resolve the promise that we return from then. And that's going to trigger this resolution handler that we attach to the returned promise. So how do we capture this? Well, that's the return value of the resolution handler. We call it here, so we can just assign the return value to a variable. We check if the return value is an instance of my promise, and then if it is, we'll call then, and here we should resolve the promise that we return from then. So we need to store a reference to this promise. Because the resolution handler and the new promise are inherently associated with each other, I'm going to create a new object that stores references to both of them and then push that object to my resolution queue. Because items in the resolution queue are objects now, we have to change this to refer to the function by saying resolution.handler. And here we can resolve the associated promise. Let's move on to the next test. It says chaining works with non-promise return values. So what we're testing here is that if we return something that is not a promise, then the next promise will be resolved immediately with that value. Now at the moment, if we return something that is not a promise, we're not even resolving the associated promise. So this function is never called. We need another condition here. Now the test works, but I noticed that we should add a test here to make sure that the return value exists. Let's look at the next test. It says resolution handlers can be attached when promise is resolved. If the promise is resolved already, it should still be possible to call then with a new handler. That handler will simply be invoked immediately with the stored value of the promise. So here we call promise.then and give it a handler, and inside the handler we wait for 100 milliseconds and then attach a new handler to that same promise. If I run the test, we'll see that this fails. This inner function is never going to be called. So we'll need to add a check to then. So if state is resolved, we have to do something special. In the constructor, I give the state the initial value of pending. And if the state is resolved, we actually just want to process this resolution handler and the promise we just created and pushed into the resolution queue. Now we could maybe just call this .resolve, but the problem is we don't have this value that is normally passed into resolve. So the first thing we have to do is we have to store that value. So I assign the value to this ._value, and I change the code below to refer to this ._value instead of just value. And now I can extract this part to its own method. I'll call this new method both in the resolve method and in then. The test still fails because I forgot to change the value to resolved in this resolve function. So let's do that. Okay, let's move on to the next test. Calling resolve second time has no effect. So in this case, this call to resolve should have no effect whatsoever. The test fails because every time we call resolve, we set this ._value to the new value passed into resolve. So let's fix this. We only do anything if the state is pending, otherwise we'll just skip the whole method. Next, rejection handler is called when promise is rejected. Rejection handler refers to the function that is passed into promise.catch. And what we're testing here is that if we reject the promise, then the rejection handler should be called. If we run the test, the first error we get is promise.catch is not a function. Okay, so we need a catch method. And I already know that the next error is going to be reject is not a function, so we need a reject method as well. And we need to pass the reject method into the executor. Okay, and now we get this test exited without ending that we've seen a few times before. And that just tells us that the handler is never called and t.end is never called either. So we want to do basically the same thing that we do in resolve, but in this instance we want to save the handlers into another array. So I'm going to call that array rejection queue. Okay, our reject method is almost the same as resolve method. The difference is that instead of this._value, we're going to store the argument into a variable called rejection reason. And the state that we're going to transition into is called rejection. And then instead of running the resolution handlers, we'll run the rejection handlers. And I need to implement a method called run rejection handlers next. Run rejection handlers is almost the same as run resolution handlers. The difference is this time instead of iterating through resolution queue, we iterate through the rejection queue. And instead of calling the handler with the value, we call it with the rejection reason. Next, we have to implement catch. Again, catch is almost the same as its counterpart. Then the difference is that instead of storing the handlers to the resolution queue, we push them to the rejection queue. And instead of checking if the state is resolved, we check if the state is rejected. And then we run the rejection handlers. And that takes care of that test. Let's move on to the next one. So this test says chaining works with rejection handlers, but I think actually a better description would be rejections are passed downstream. What we're testing here is that if I reject the original promise, then we'll skip all the following resolution handlers and go directly into this rejection handler that we're attaching here right at the bottom of this chain. Now this doesn't work yet because the only thing we do when a promise is rejected is we run the rejection handlers. So in the reject method, in addition to running all the rejection handlers associated with this promise, we should also go through the resolution queue and reject all the promises that we return from the then method. This way the errors will bubble up to the bottom of the chain, and this function should be invoked as well. Okay, all the tests passed so far, so let's go to the next test. So what this test is called rejecting promises returned from resolution handlers are called properly. So what this is testing is that if we return a promise from a resolution handler, and if that promise rejects, then the rejection handler attached to that returned promise should be invoked. So let's go here. So this is where we resolve the promise if the returned promise is resolved. Now to do the same, but for rejections, we can simply call catch here. And inside catch, we just reject the promise returned from then. And that works. Next, rejection handlers catch synchronous errors in resolution handlers. What we're testing here is if I throw an error in a resolution handler, that should be treated as a rejection, and basically there's a rejection handler down below should be invoked with the error. If we run the test, we notice that the error is thrown, but it's never caught. So where can we catch that error? Well, we can catch it here, where we call the handler in the first place. We'll wrap it in a try block, and then we simply catch the error. And then we simply reject the associated promise with the error. And now our test passes. Let's move on to the next one. It says, rejection handlers catch synchronous errors in the executor function. So we're basically testing the same thing, but for the executor function instead. What we'll have to do is wrap the executor invocation in a try block, catch the error, and then reject the promise with the error. Now this doesn't work yet, and the reason is that we throw an error before we even attach any handlers to the promise. And inside then, we don't handle the case where this promise is already rejected, so we'll have to add that in. So we just reject the new promise with the rejection reason. It says rejection handlers catch synchronous errors. So this is the same that we did previously for the then method. So if the rejection handler throws an error, that should be treated as a rejection as well. So what we'll have to do here is we have to wrap the call to the rejection handler in a try block, and then catch the error and reject the next promise with that error. Okay, let's move on to the next test. So this is just testing that if we return a new promise from a rejection handler, it should function just the same as when we call then. So there's really nothing new here, and it works right out of the box because of the way that we implemented catch. It's basically the same thing as then, but we run the rejection handlers instead of running the resolution handlers. Then we return a new promise, and the way we treat the promise is identical with catch and then. Move on to the next test. It says rejecting promises returned from rejection handlers are called properly. So in this case, we test that if the promise returned from a rejection handler is rejected, then that rejection should be called in the following rejection handlers. Now this doesn't work yet. It's because we have to add a couple of lines of code. Now earlier we added these lines of code to run resolution handlers method, and we have to do the same thing up here as well. Just change this to rejection. Let's move on to the next test. It says second argument in then is treated as a rejection handler. So as you may know, then takes two arguments. First is a resolution handler, and then it also takes a rejection handler, and we haven't implemented that yet. So let's do that now. The only thing we have to do here is just push that rejection handler into the rejection queue. Whoops, and we get a bunch of errors, and that's because we'll first have to check if this rejection handler actually is a function at all. Okay, then on to our last test. The description is second argument in then is attached to the promise then is called on. So I think this is a common pitfall with people who are new to promises. When we pass this rejection handler into then, that's not the same as just chaining it with catch, because this rejection handler is going to be attached to the original promise, whereas the rejection handler that we pass into catch is going to be attached to the promise that is returned from this then method. And here we see why that's important. If we return a promise that rejects, then it's not going to be caught here. This function is never run. Instead, it's going to be caught here down below. So this is why I don't really ever use this feature, this second argument to then. I just always add a catch method at the bottom of the chain. And we don't really have to do anything to make this test pass. I just wanted to add it there because this is a point of confusion for many people. So it's just something that is good to keep in mind when you're programming with promises. Okay, that's it for this video. We have a reasonable promise implementation. It's not a perfect implementation. There are some edge cases that we don't handle, and it's probably not the most performant, fastest promise implementation out there. This is purely for educational purposes. The goal for this video was to demystify promises a little bit and just take away some of that magic. And hopefully you learned something. Leave a comment if you have any questions, and see you in the next video. Thank you for watching.